Hello. Thank you for coming to this 1 hour seminar. Today we have Nadia. Would you like to pronounce your last name?
Strelitskaya.
Strelitskaya. It's not that difficult. She's an assistant professor of applied economics at Oregon State University. Some of her research is in food labeling, food choices, and the various anti-obesity and healthy diet policies, advertising, long-term effects of information on demand, and social influences on consumer behavior. She knows a lot about behavioral economics. She's going to talk about that today. She has a new paper on that topic. I know that she's also working out in wine. She used to have a fellowship from fermentation science something. And instead of choosing yogurt, bread, or kombucha, she chose wine, which is a good decision. Okay.
Yeah.
Now to you, maybe for 35 minutes.
Yeah, thank you for this introduction. And this really shows that I haven't updated my website in a while. I have done work on yogurt as well, surprisingly. But today I'm going to talk about something that is a new research project, and we haven't really presented it anywhere. So if you have comments, that would actually be very helpful. So it's not one of those presentations that you have already submitted somewhere and you're like, yeah, I have to present something, but no, this time I really want you to probably hammer down on what's wrong. And I'm also very used to interruptions. So because it's work in progress, if something doesn't make sense, feel free to let me know right away and we'll try to stop and talk about it. Also the 1 hour mark. I have no guarantees. It won't be over 1 hour for sure, but I have no idea as in how long it will take us because, again, I'm presenting this for the first time.
I'm teaching at 12.
So, yeah, you know, yeah. No more than an hour, but we might be done in 20 minutes. Okay, so what we are going to work today is work with my graduate student and my colleague at Oregon State University, and that is done with the Build Back Better grant back from the Biden administration that had a big investment into local economies. And one of the things that happened in Oregon is that there was a large grant based on forestry, right? Forestry industry. And we're going to talk a little bit about forestry ends up being very important to Oregon State.
Sorry.
That's okay.
Even though it says sharing, there wasn't.
Okay.
Now, yeah.
Okay.
You want me to mark up the window on
So this is one of those research projects that you start based on the one hand, the interest of the industry and the existing projects on campus. So it's a very large collaboration in general, the grant, with a lot of scientists who are developing a lot of safety equipment and a lot of safety video processing tools to, let's say, identify the best harvesting approaches. And there's another team that does exoskeleton work, and all of that is very exciting, and we get to do almost none of it. When we started, we thought that maybe we would be able to actually test some of those things in the field, but given the time that it takes to actually develop an exoskeleton or even a video interface, and the time that we have to deliver our economic research, we didn't get to do that, which led us to try to examine safety decisions using basically a set of experiments. We couldn't get out in the field to do them, so we brought people into the lab. While we were doing safety decisions, because that is of interest to the industry, for us, we were more interested in like the economic underpinnings of how safety decisions actually work. And in that sense, we wanted to see, well, first of all, the very long-standing discussion on prospect theory versus expected utility theory, and what represents behavior better. But also, when we are looking at forestry, we often see decisions that have independent risk over period, but you have the same people, the same decision makers making decisions again and again. And over time, they acquire their own personal experience with the realized risk. So even when they know what the objective measures of the risk is, or they're provided it, they might personally perceive risk somewhat different. Or they might have different risk preferences that are influenced by their history of, let's say, experiencing some type of a risk event. So we were interested in digging into this a little bit more. Okay, so first I'm going to talk about forestry and in general why we care about it. That probably won't take that long. And then we're going to go and talk about why does it even matter? You know, there are a lot of papers talking about prospect theory, and we all know that, yeah, there are a lot of times when it fits better, but it's really a big pain to actually deal with the data and try to incorporate it into your existing models or existing research. So does it really matter that much? And then we're going to start switching towards how we deal with time in this particular paper. And I'm going to say right away that we're not going to do hyperbolic discounting or discounting in general. We're just talking about time as in like this repeated decision making that allows you to accumulate your own personal history of, let's say, injury exposure. And then I'm going to discuss the experimental design, talk about the data so far, and then I have like this very vague additional analysis needed, which is where I hope that you will jump in and tell me that this is where I'm not convinced, and this type of figure or research or whatever would be very helpful. Okay, so forestry in general is a very large industry in the States. It contributes to annually approximately 300 billion to the GDP. It has 950,000 jobs that are somewhat connected to, primarily connected to forestry in the country. And one of the things that really make it very important in Oregon is the fact that it's a very important rural type industry. A lot of rural counties in Oregon have been experiencing people leaving. So that erodes the tax base, that makes all of the local services decrease and lose quality. So there is a lot of interest on local municipality level to figure out how you can maintain the communities that already exist. And one of the big employer in some of those rural communities is going to be forestry. One thing that is really kind of striking about forestry is that it has a very, very high fatality rate. And yes, you know, you look at it and you're like, oh yeah, it's 27 times higher than the average across occupations. But a lot of occupations are really pretty minimal risk, right? But even across top, like, things that people perceive as kind of risky occupations like mining or police work, you actually find that forestry is still like around 10 times higher risk than being a police officer or being, you know, working in mining. The mining, I thought that I would do that because, of course, Western Australia has a very large mining presence, so a lot of people might be familiar with it, but the range is so large because the sector definition in different studies will vary a lot based on what you actually include in the mining or not. Note that this is also just the fatality rate, right? So this is the risk that led to somebody actually dying on the job. It's also done per FTE, so it doesn't mean that every year there are 100 people dying, in forestry employment, because a lot of people actually work part-time, or they do not have enough hours to constitute a full-time employment. In terms of Pacific Northwest, which is the region that Oregon is generally economically and socially incorporated into, Oregon and Washington, Oregon is going to be accounting for 10% of all lumber production in the US. So it's a very big contributor to a big sector in the States. And Pacific Northwest in general is the largest producer of softwood lumber and plywood. So things that are very commonly used in construction, especially cheap construction. So that becomes quite important as well for your construction industry, your real estate outcomes, and so on. Sorry, okay. In Oregon, around 48%, so almost half of all land is actually forest land, which is higher than average across US states. Moreover, I'm not sure you see the map really well, but right over here, there is a Cascade Mountain Range. So that Cascade Mountain Range divides climatically Oregon from the dry high desert, or also mountain ranges up here, from much more rainforest, moderate rainforest over here with a lot of rainfall. This area, which has a lot of large private, small private timber operations, actually is very good at growing lumber very, very quickly. It mostly produces Douglas fir, which is very straight, can grow very large. It's very well suited to the local area. And almost all of it is on mountain slopes. So there is a coastal range up here, and this is where the coastal wood operations are, and this is the Cascades. So all of them are going to be pretty steep. This is Oregon in general responsible for 4% of total US forest land, and it's one of the states that has the highest proportion of that forest land actually dedicated to timber production. So not only it's just forest, it's forest specifically dedicated to the economic activity of producing timber. It is higher than the national average, and in absolute terms, the only state that has more timber in the States is Georgia. So it's a very steep harvesting terrain, and I'm going to show it in a minute. 3% of total state employment is associated with forestry. And in rural counties, there are maybe like 4 or 5 counties specifically in which over 10% of total employment goes back to forestry. But in general, the industry has not been doing great in terms of outcomes for rural communities, because a lot of processing plants have been closing. So just in 2024, so last year, there were 7 mills that closed down, and that removed 700 jobs in one go. That doesn't seem like necessarily a very large number, but then Oregon is not actually a very large state by population. And I don't know that number actually on top of my head. But because you face both economic pressures in which you cannot maintain the operations that already existed because of competitive pressure, particularly from overseas processing, and because of the risky terrain that people face in the profession, you have kind of trade-offs that people have to make between how much you invest into new safety procedures versus how much do you try to cut costs to actually remain competitive price-wise. So logging on slopes is pretty difficult, and there is a lot of regulations that defines how you're able to log on slopes. But for example, in this Cascade area, you will have a lot of either tethered machinery production, in which to increase, each machinery equipment is certified to a particular slope that it can actually remain stable on. You can increase that slope by putting a steel cable that you can kind of see somewhat in here that will anchor your machinery somewhat. But of course, it's not as good if it was flat. So eventually you have to switch to the so-called skyline harvesting, in which you have one of those machines on one of the tops of the hills, and you basically run a skyline that you chop the wood somewhere down there with a chainsaw, and then you collect it, like you hook it to the skyline, and then you pull it off. And that means that a lot of the actual felling of the trees is very manual, right? And really brings with it quite a lot of risks that are not just a tree will fall on you, but just, for example, the exoskeleton group is working a lot on stress injuries, because you're carrying a heavy chainsaw and you're bending, you have a lot of stress on your lower back, and over time, you're going to be having a labor force that is unable to actually continue working, which is already a problem, because inherently you can only collect timber in locations where timber grows, and all of it is rural, and rural communities, the younger people are already leaving. So you're already facing a lot of challenges with retaining your potential employees. Okay, so far in terms of the state of literature in risk, there is a lot of research in fire risk, because Oregon is a very high fire risk state. There is a lot of fire, there is a lot of fuel load, because the trees grow really quite fast. And for a very long time, the only type of fire management strategy was a fire suppression strategy, which means that, there is a lot of potential for fires to start up and to spread. So there is a lot of analysis on how risks of fires affect decision making, and there is also a lot of analysis on how your risky outcomes of, well, how much of your stand actually ends up surviving to harvest time based on environmental risks. But there is less research on the safety risks that people face in terms of economics research. So there's a lot of occupational safety research on that, but less so on how managers in those operations actually make their decisions, which is where we think this paper kind of comes in. Because the terrain is quite diverse, different managers in different locations face very diverse risk profiles. And because people move and change employment, you will have people who started out in one sort of operation moving to a very different risk profile operation, right? So you can move from a skyline kind of harvest processing to a more flat area, they also exist, or to winch or even helicopter forest harvesting, which is not as common, but still exists in the state. As workers move around, all of their past experiences stay with them. So that's really what we want to see. Does your initial exposure to a particular setup of risk affect your decision long term? Or do you just adapt over time? So, okay, so why do we care about the prospect theory piece? If you have managers that behave as expected utility maximizers, their risk preferences are stable, right? So once you have a risk preference, you've identified it, you kind of know how to communicate with that particular person. So you can develop communication strategies that appeal either to very risk-averse or risk-seeking people, and you can develop self-selection treatments in which people who are, let's say, risk-seeking will end up finding material that targets risk information and presents risk information to improve the outcomes that we care about, like, for example, safety, without necessarily getting in conflict with their own set of risk preferences. The same way with somebody who is very risk averse, right? How do you communicate that? Once you know that this particular, let's say, company or that particular area is managed by a set of risk averse managers, you can communicate accordingly. This is very important for the outreach office in the state, because they actually establish very long-term relationships with people, and they try to communicate new, let's say, developments by the university for them. If, however, you have managers whose behavior is better described by being by prospect theory, you have a couple of things happening. You might underweight common small injuries. So you might consistently underinvest in frequent safety needs. So your stress injuries, your fractures, things that don't seem to be really that bad, but over time, they actually do impact your bottom line. And they also, more importantly, from our perspective, impact the likelihood of the labor force remaining there and still remaining in the rural community, which is part of the overall kind of grand mission of revitalizing your rural communities. They might also overinvest in rare catastrophic risk prevention. And yes, forestry is very risky. It's riskier than other professions. But in absolute numbers, it's still, you know, very drastic outcomes are still pretty rare. So in that case, your communication and policy might need to adapt to biased and context-dependent choices. In addition to that, we are bringing in our piece about your personal history of, like, when you were managing a place, how many accidents did it actually have? Did it impact either your decision or even your risk preference itself? How does that work out? So this is the motivation for our work. Just as a little recap, if we were to use cumulative prospect theory, which we would, we basically are working with two different pieces, right? On the one hand, we have a value function that functions somewhat differently on the gains domain and the losses domain. And the value function can be characterized by two coefficients or parameters. The first parameter is let's say omega, that talks about the curvature of your value function. So basically the general risk aversion, right? The shape of it. But then we also have lambda that on the loss domain scales up that impact of your risk aversion, making it higher, right? So you become more risk-seeking in the loss domain comparatively to your behavior in the gain domain. And of course, the whole idea that we can talk about gains and losses is tied to the fact that we have a reference point, right? So there is some reference point somewhere, and that is something that is quite hard to actually determine if you're in the field, and often becomes a sticking point for a lot of your research. But then additionally, we talk about probability weighting, right? Part of the cumulative prospect theory is that in addition to this reactions to gains and losses, you also have different reactions to your objective probabilities that are associated with risky outcomes. And you might be overweighing small probabilities and underweighing large probabilities. And in this particular case, we're working with a prelates family of functions, which basically just has one coefficient on it that will shape it relative to the straight diagonal, right? Which would be the original probability. Okay, sequential decisions outside of exponential and hyperbolic discounting, which we don't address, we have two potential considerations. First of all, you can think of it as learning, right? So let's say over time, you make decisions, you see what risky outcomes actually happen, and maybe you actually learn and update your belief about the probability distribution for particular events. That is not something that we're really interested in, because if you're just learning, you might be talking about whether you learn efficiently or not, but that doesn't mean that your risk preferences themselves are changing. That just means that you're finding more about environments that is highly uncertain. What we care about is whether past experiences, when you know your risk very well already, whether those past experiences actually end up changing your risk preferences themselves, which violates pretty much the basis of our general expected utility risk aversion approaches. Okay, so experimental design. We have people coming in and making decisions in the lab. We are supplying them with a baseline participation payment, which is around $5, and then all of their earnings on top of those $5 are based on their decisions within the experiment. So we have kind of two big parts to what they actually do. First, we set them up, and I'm going to walk through those tasks in more detail. But first, we just provide them with a background. We tell them, imagine that you are a forestry manager. This is what you're facing. You know from your past documentation that this is approximately how often the accidents happen. This is how much you will earn when an accident happens. So we remove pretty much all of the risk. We are not even expecting people to be very good profit maximizers, right? So we're actually just telling them what their outcomes would be in any particular scenario with safety equipment, without safety equipment, if an accident happens or if an accident doesn't happen. So it's very simplified, very streamlined. But we have two risk environments set up. In one, we have a high probability of low loss scenario, in which each each period in which you make decisions, there is a pretty high probability that something will happen, but it won't impact your profits that much. On the other hand, in the low probability, high loss scenario, you have low probability of risk being realized, but if it does happen, it will really reduce your profit significantly. After people go through 10 periods each on either the high probability low loss and then the low probability low loss, or we change the order that people face those two treatments in, we then follow Tanaka, Kammerer, and Nguyen paper on prospect theory parameter elicitation. So this paper looked at Vietnamese farmers and developed a switching game in which people have to make three decisions that allow researchers to basically estimate all of the three parameters for the cumulative prospect model. So we do that after they have already done their production decisions, and then we try to work with this. What the benefit of this risk elicitation is that it actually collapses into expected utility. So when you are dealing with it, if you have expected utility maximizers that behave according to expected utility, you would be able to accommodate their behavior within that elicitation procedure. Okay, so
Maybe 10
Yeah.
minutes.
okay, let's deal with that. Okay. Okay, so the high probability, low level risk, you're functioning as a manager of a forestry company. Forestry is a risky profession. We have a big walkthrough about the risks of forestry before this starts. If workers are injured, you produce less, profit falls. But the general, as I'm saying, decisions that people actually make is pretty simple. They just need to decide whether they're going to lease safety equipment or not lease safety equipment. And we give all outcomes to them. So we say, okay, if you do not lease safety equipment, 20% chance you are not going to have any injuries, and you're going to make 125, but 80% chance that you're actually going to lose money and make 105. If you lease safety equipment, you now have a slightly higher chance of no injuries, right? And even if injuries occur, if no injuries occur, you still have to pay for that lease equipment. So you make less, and then you have a lower chance of injuries. But if they do occur, they're not as bad for you because you reduce the impact that it has. Okay, and opposite, low probability, high level risk. So you just have, again, the same decision, whether you're hiring safety equipment or not. As each individual participant, you start out with either high probability, low level, or low probability, high level risk. You do 10 decisions in a row of that. And each time you make a decision, you will actually have a reminder of your previous outcomes. So it's not just that you make a decision and then you forgot what you did five periods back. Each time that you make a decision, it gets recorded in a table and you see it on the very top of your decision screen. So we're really trying to make people aware of that history, that, whether an injury occurred for them or not. Okay, and then we have that switching task, which is basically already published. So let's just give, for the interest of time, just assume that it works. Over time, by seeing at which point they switched in those 3 different tasks, we can narrow down the bands on the curvature of the value function, the lambda, and the probability weighing function. So this is a bit more technical that we want to do. So we went ahead, we got 200 people in. Mostly they are college students, so like 40% of them are under 21, but we have a fair bit of people that are slightly older. We did recruit through the Forestry College. So the Forestry College in Oregon State is one of the largest forestry colleges in the country. There are a lot of people there who actually end up training specifically to go into forestry. We would have preferred to work with managers, but it's very hard to actually get them to respond to anything, particularly in numbers that are high enough to make sense. Okay, so first, let's go the easy thing, the elicitation of whether your expected utility maximizer or prospect theory fits better. If you were expected utility maximizer or acting according to expected utility, when you were switching, independent of how risk averse or risk seeking you would be, based on how the tasks would be designed, people should be falling in that highlighted areas in where they're actually switching from having safety equipment to not having safety equipment. We see that most people in our sample do not actually switch where we expect them to switch. They all switch in this wide kind of area that tells us that no, they don't seem to be consistent across different sort of behaviors. So using that, we can narrow and estimate the curvature, the loss aversion, and the pellets weighting. And this is kind of what we find. So we find that we do overweigh small probabilities and underweigh large ones. You see that there are two colors here. So those two colors are based on whether you were first exposed to the high probability treatment or the low probability treatment. And you see that people who first faced the high probability treatment of low level risk and only then followed it with the low probability of a high level risk, they have a different shape of the thing. That's pretty much the only thing that you need to take away from it. And the only thing that I can say is that it seems that the original environment, right, the risk environment that you were facing, whether it had more drastic but less common risk or risk that is very common but not that scary, that affects your risk preferences at the very end of the experiment. So we did this Tanaka part after both groups were exposed to both types of treatments, right? So we would think that that would average out if that were changing based on discovery or learning. And then again, here are the people who start out with a high probability, low level risk, and then they go on to the low probability, high level risk. And those are the people that have the same thing, but just switched in order. You see that the red line is just the actual risk that was realized because it was random within the experiment. But you see that somehow there is a very big disconnect and adjustment for one group. And for the other groups, the actual use of safety equipment, which is the blue line, was kind of jumping more all over the place and didn't seem to be that different as you have switched the risk environment. Which leads us to the last thing that we thought about to do is defining things like formative injuries versus most recent injuries. There is a lot of debate in the literature what counts formative and what counts as recent injury. So we just went ahead and said that, okay, let's try with defining formative injuries as, for example, the 3 first periods, the 4 first periods, 5 or 6 first periods that people had, and recent injuries as the 3 last periods, 4 last periods, and so on. But however we define it, we find that in terms of choice, which is just a binary variable of whether you decide to use safety equipment or not use safety equipment, you're much more likely to use safety equipment if you have recently personally experienced an injury in your production, but also formative injuries still hold quite a bit of sway, even if you control for the recent injuries. So it seems like the original exposure, even in the first 3 periods out of 10 periods, does still drag on in the later decision-making process. Okay, so that's pretty much it. Did I run over time?
No.
Let's be positive. First, are there any questions from PhD students? Sorry. No, yes, Ben.
Yeah, so this is from the perspective of a forest manager. So, and the Tanaka Tanaka setup is about, monetary gains and monetary losses. But I mean, this sort of strikes me as being a different type of risk, because I'm a manager, and I care about profits, and that's the Botanica risk. But I also care about my employees, and I don't want them to lose fingers. Is that sort of factored into the risk calculus, how much you actually care for your employees? Because I think that would probably be quite an important consideration in this setting.
Yeah, you would think that it should. The thing, we have two different tasks, right? And we introduce them all within the setting of forestry. So we are very much trying to make people think of forestry and talking about the types of injuries that can occur and so on. So people should have it at least primed in their mind. Now, depending on how exactly they're going to be prone to actually believe it, or whether they're just going to think specifically about the money outcomes, we're not sure, right? But that's also true for the managers. It seems like, particularly this analysis that looks about the formative injuries and recent injuries, and this one that doesn't rely at all on Tanaka, right? It just relies on whether you decide to lease safety equipment or not lease safety equipment, and you have those reminders. And I think that that's right, that maybe you would have people who are leasing safety equipment just based on the fact that they care and they want to protect their employees more. But on the other hand, forestry is a very weird profession in which a lot of issues are actually connected to making people use safety equipment, which is why we had to switch from actually forestry workers to managers, because pretty much no forestry worker wants to have more protective equipment for a bunch of reasons that seem to come out in conversations. It's bulky, it's inconvenient, but it's also not how things are done. I think that there are also going to be a lot of managers who are not going to be using the equipment because they're thinking that, well, I'm going to lose workers because they are going to go somewhere where they don't have to put this on and they don't have to comply with it. Because, again, we're functioning in the US environment, which I gather can be quite different from the Australian safety, occupational safety environment.
Anna? Then Sarah,
Yeah.
then Michael.
Yeah, I think touching on your point, Nadia, could you tell us a bit more about like the regulations and what they are actually obliged to do in terms of looking after the employees, and to what degree any of those injuries would revert back to the manager in terms of liability or?
Well, so US is a very litigious country. And the way that it usually gets back on the company, that the company has to carry liability insurance. If you have a lot of claims based on liability insurance, you would have to pay more for your, for example, insurance that you're mandated to carry to be certified. So that's one way that having a lot of injuries will actually reduce your things. There are also, you know, companies, depending on their setup, can provide health insurance. And again, from the company's perspective, they're going to have to pay more over time if they're experiencing a high level of accidents. In terms of the actual regulation, on the state level, there is regulation about, for example, how to deal with the risk of fire, but there isn't quite as much stringent regulation in terms of occupational safety. Like, you have to, in some cases, wear some high visibility, but it's not really defined what actually constitutes as high visibility. You have to wear helmets when you're on site, but with a lot of the things that you're actually doing, the injuries that you're working with are not something that are going to be easily addressed with a helmet. So in terms of what you can actually do, there isn't like a universal safety government-driven regulation that will tell you you have to do this for your workers, right? So it mostly comes down to what you think it's going to have as an impact on your bottom line, especially in a situation in which a lot of companies have to close or narrow down their operations because they cannot retain people. And the retaining people comes back to, okay, if you have to retain people, my other push is actually to protect the workers that I have, right? Because a lot of this work requires training that is not very easy to acquire. So it's going to be training on the job, and there is a fair amount of investment in each labor that you're going to have.
So there's an additional cost of having safety equipment, like all that, losing staff.
Well, yeah, losing staff, but there is also, if you don't have safety equipment and you like all of your people have to retire before they hit 35 because they cannot do anything anymore, or they do everything much more slowly. So it's a very complex problem that, like, part of the reason that we couldn't actually end up doing testing some of the safety equipment that was done is because even people designing them don't actually know what they're going to do with the safety outcomes in the field, because it really has a very high dependence on how people use it, what type of environment it is. So this is like a very abstracted step away, like, okay, if we knew all of those things, at least let's figure out the behavior of people. And then as we find out more about how safety equipment works, what it can do, then we'll be able to at least have that piece in place.
Sarah?
That pretty much answered my question. So,
Michael?
yeah.
I want to go back to Ben's question. Was the experiment incentivized?
Yes.
So they were being given payoffs based upon one of the draws or whatever?
Oh no, each time they made a decision, and let's say they leased safety equipment and they did not have an accident and they made 115, they earned 115 lab dollars and they had it in their thing. And over time they had, 20 periods of that. And then those lab dollars were converted. And I think on average, the payout was something like $30.
It's just, I think, I'm trying to work out whether you could re-rationalize the choices they were making, not in terms of expected payoff, but in terms of injury, as in, or whether those are they perfectly correlated? So I would end up with exactly the same outcome if I said that they're not interested in the lab dollars, they're interested in minimizing expected injuries. Would the analysis end up exactly the same outcome, or is it?
Yeah, I don't know. Partly because I'm not sure how to separate those two things, right? But also that's the same thing in the field. Like, you don't know how much you actually care, especially a lot of those things are actually pretty big companies, right? It's one thing when you think about, like, you are a small manager making a decision for, let's say, your crew of 20 people and you know them. And it's a very different decision, as we know psychologically, if you have a crew somewhere like in the States that you haven't even been to, that has 100 people that you've never seen, and you have, 10 of those. Your psychological pressure in reality might be different based on those things as well.
Just in terms of rationalizing the choices you're seeing by your students in a lab, where there's some way of digging out whether or not they're not just being motivated by their lab dollars, but they're actually that they have some sense of, oh, I feel a bit uncomfortable about trying to maximize my return, rather than just, and I'm hypothetically, but injuring workers with conceptual workers. Well, yeah, I think that would be interesting to see, because it does seem like a different setup rather than just the normal experiments where it's just a payoff for.
Yeah, actually, it's good because we have a survey that in the end asks whether they've had any personal experiences of injury and so on, and like also what connection to forestry they have. So maybe if we can separate it based on groups that had personally been injured, and they might, see whether they behave any differently from people who have not had injuries.
Do you have any measures of empathy?
No. But that would be good, but no.
So what you could do is you could run this game, equivalent game, just on monetary. Don't mention injury and see what your results are. Just on a monetary payoff for something, and then you can run. Well, perhaps the only way to simulate pain is you get a bunch of actors, and then they have an injury module, and that people sort of make lots of injured noises.
Yeah, I definitely see the IRB at
So,
Oregon State being really happy.
Yeah, so you have a few problems with HR, inequity.
Could you have an alternative payoff that's going to a third party, like some charity that's supporting injured workers
to the fund?
Yeah.
So this is like one of these things in economic experiments. It's really hard to replicate because it's real pain amongst your workers who you know. It's not just like a monetary payoff.
Yeah, no, I think it's a good point. And I think that like trying to get at it as either, you tend to be more empathetic if you have experienced something like that yourself. So maybe divide, like the closest that I can do is to see whether you've had injuries, right? And see whether people who had them behave any different from people who didn't. Yeah, or collect new data, but collecting new data is like a step. Yeah, it's a step.
So there might be different peoples who play this game, like there's the 19th century mill owner who doesn't care, or there are, people who are more enlightened.
Well, we also have
generally take account of.
We have a politics question, like whether you are yourself identify as liberal, progressive, conservative. So they have a whole bunch of things, right? And maybe we can also look at that and see whether that actually impacts it. So that's a good idea. Thank you.
Any other question? Emma?
What about the age group? I know you said most of them were younger, but could you differentiate responses based on sort of generational gaps or
so
general life experience kind of thing?
I don't show that, but we actually run a whole bunch of regressions that also include demographic controls, and the only thing that is consistently kind of showing up as different is gender, which is very, very in line with a lot of risk literature, right? So, but age does not, either it's because we don't have enough of an age variation or not enough power to identify them. But yeah.
Sarah, and then you.
I'm curious, do you have any people who always have safety equipment? They just always forever choose it. Yeah.
Yeah. So we had 200 people that we recruited. And then at the end, most of our analysis is done with 157 people because we have that group of people that just always use safety equipment, which is, fair enough, but it doesn't give us actual like variation or things that we need to estimate, let's say, the switching point in Tanaka, because they also in Tanaka never switch to not having safety equipment.
That could be an interesting group. Bring them back in for demographic.
Oh yeah, we have them in for demographics, so maybe checking whether they're significantly different from that or not.
Whether they've had previously injuries themselves.
Yeah. Okay, so maybe they might be more
like you always wear your helmet if you're cycling, or if you fell off.
Okay, so probability of basically being a non-switcher based on previous injury. Yeah.
I guess she already answered, like the group you analyzed was made of 200 people.
Yeah, 200 people, and they made 20 decisions plus 3 switching decisions, so 23, right? Yeah, but not all of them, as I'm saying, we dropped like however many because there were no differences, no switching.
Any other questions? I have one otherwise. No? Okay.
Okay.
We had one more question. I'm trying to think how to ask it nicely. This we had a similar presentation, I would say. Actually, Steve is saving me. I think I should ask you in private. Steve, would you like to ask your question?
Steve.
Steve,
Give us a sign.
I will mute you. Now. Now you're muted.
It's exciting.
Okay, I'm muted. Can you hear me now?
Oh, yes.
Okay, so thanks for your talk, Nadia. I have actually a lot of questions, so I'm only going to ask one, probably because it might be of more interest to the audience. It's a less usual one, I think. I'm actually quite interested in the fact that you found long memory effects from past injuries. And I was wondering whether you measured the decay rate as a function of time, how far back. So, 10 years ago, 8 years ago, and so on. Because if you look at the shape of the decay rate curve of that kind of thing, I was wondering whether you also found non-exponential curve, and most particularly a power law, of which the hyperbolic function is a specific example. And there are specific techniques to measure that. Like, for example, just mentioned the memory kernels of fractional operators, which has been recently used quite a bit by econometricians. Actually, since 1980, really. But I was just wondering whether that's something you had to look at. So in other words...
Yeah,
okay.
We haven't. I think that's a good idea. The closest that we get to it at this stage, and we're still working on it, but is kind of seeing whether, formative injuries, we increase how close the formative injuries as defined are to the present. So we move closer and closer, and at 6, they're just 4 periods away from where you are currently located, right? And it doesn't seem to be really changing all that much, but we do know that, the significance of those is less. I mean, it's very hard to actually take that seriously, the difference in significance with those number of observations, and because we just do specifications, right? So I don't want to overstate what we're finding and say that there is no decay. It's more that looking at what we have, it doesn't seem like there is a decay specifically. And also, I think that part of it is maybe that, at least conceptually, I was thinking of formative experiences as, like the very first ones. Like, your first experiences still remain your first experiences. Your other, like the middle of your 20 periods, they kind of fall away because you don't remember. They're nothing special. But the very first time you play your game or you make your decision, that in my head might have more of a memorable impression. But again, it's not really something that I'm testing. So yeah.
I mean, there are a lot of other things that you could look at, as, for example, the magnitude, or sort of say the seriousness of the first experience, how serious that magnitude, and also the timing, how far away, and how that impacts on the importance of later. So, for example, if you have an accident 10 years ago, that would be the first one, and then you have another one, non-negligible one, 5 years ago, so 5 years later, how does the magnitude, for example, of the first one affect the impact of the second one on your current behavior and what you're and the decisions you're going to make? The other thing is, okay, that's one thing. The other thing is, following up on what Michael was saying, is that I don't know, I didn't catch from what you said how the workers themselves see things relative to what they believe their managers, how they see things, and how the local managers see things relative to what the non-local ones do. So in a future experiment, would it make any sense to have the two types in there and see how that impacts the kind of decisions they make and the strategies and so on, how much they're willing to invest in safety equipment and so on?
Sorry, Steve, I cannot allow Nadia to respond because we're out of time.
We can have a call.
You can have a call.
That's it. I'm done.
To meet with Nadia, she's very nice. Okay, thank you very much.